This video is going to be a quick review, hopefully quick, of the explicit formula in regards to sequences. So if you recall, sequences are a list of numbers or objects that are in a pattern. So if I had the sequence 1, 4, 9, 16, 25, etc., the special pattern for this sequence would be perfect squares. So these are called the different terms. So these are terms. And the notation that we use for these is we would say A sub 1 is the first term, A sub 2 is the second term, A sub 3 is the third term, and so on. And then as the pattern continues all the way out here, we would call this the nth term. So we go all the way out forever. A dot 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 would mean that we have an infinite sequence. If the sequence ended right there, then that would just be a sequence of 5 terms. Okay, so we have two specific types of sequences that we study, and then the rest of them are just kind of a general sense. So the first is arithmetic, and this just means that you are consistently adding the same number over and over and over again. And you could be adding a positive number or a negative number, so these are sequences that could be going up or going down. The next type of sequence that we're going to be looking at often is geometric, and that just means that we are consistently multiplying by the same number. And again, you could be multiplying by a number like 2, or you could be multiplying by a number like 1/2. And so you can have sequences that are geometric that go up in value and go down in value. So since you guys have learned about these before, I'm just going to hit some of the points that you might have struggled with in the past. And so before I review the actual formulas, I just want to remind you guys how we could find missing terms, because that is an element of this that some students struggle with. So let's say we have the arithmetic sequence that starts with a 26. That could be the first term or the 57th term, I don't know, but somewhere in the sequence we have a 26. And then over here, 4 spots or 3 spots away from that, we have a 47. So if it's arithmetic, then I know that it's consistently adding for each of these. So I'm going to go ahead and subtract these two numbers to see how many numbers have been added. So if I subtract those, I get 21. So that means as the sequence went up 1, 2, 3 times, the sequence went up 3 times, we got to 21 that way. So I'm going to say 21 divided by 3 is 7, which means that to do this sequence, it must have gone up by 7 each time. So if this is 26, then plus 7 must be 33 for the next number, and then 40 for the next number, and then 47 for the last number. So that fits those blanks and it fits the pattern. For geometric, we're going to set up a similar scenario here. A geometric pattern, like I said, multiplies. So we're going to say it multiplied 1, 2, 3 times. 3 multiplied by something 3 times to get to 24. So for these ones, I want to see how much it has multiplied by overall. So 24 divided by 3 is 8. So when some number was multiplied by itself 3 times, it was like multiplying by 8. And this number that we multiply by is called the common ratio, so I'm going to use a variable r. So this number multiplied by itself 3 times was 8. And so if I want to solve for that, then I'm just going to go ahead and third root that, and third root that, and I get that the common ratio is 2. It must have multiplied by 2 each time. So my first number is 3, multiplied by 2 is 6, multiplied by 2 is 12, multiplied by 2 is 24. So that fits our pattern. All right, so next, you may or may not have remembered the explicit formulas. So for arithmetic, there are two ways that I've seen it written. We can say a sub n equals a sub 1 plus d times n minus 1, or you can say a sub n equals d times n minus 1 plus a sub 1. I believe this one's more common. To be honest, I'm not a fan of either one of these. But we'll work with it. I think I'll use this one since I think it's more common. So this right here would be the first term. The D stands for common difference, which is the number that you are consistently adding, whether positive or negative. So it could be plus a number if it's a positive, or it could be minus if you're subtracting. The N is the term number, and then A sub n is the term itself. So what I mean by that is if I was using a formula and I wanted to find the fifth term, 5 would be the term for this one, but A sub n actually equals 25. So the term number is the place that you're on in the sequence, like in the pattern, and then this is the term that you would actually end up seeing. Right, so that's explicit for arithmetic. For geometric, a sub n equals a sub 1 times r to the n minus 1. So with this one, here's our first term. That's just whatever the term is. N is the term number. And then r is the common ratio, which is the number that you are multiplying by each time, whether that happens to be a whole number or a fraction or whatever. Okay, so first I'm just going to go over a couple simple examples reminding you guys, if you have some nice information, how you could write these formulas. So the instructions here are going to be write the explicit formula. For the sequence. So for our first example, we're going to have a sequence that says 27, 25, 23, 21, etc. And as you can tell, this one, the pattern is it's subtracting 2 each time. So I'm going to say my common difference is -2. And then aside from that, I need to know what my first term is. And my first term is 27. And this is arithmetic. So the formula, I'm going to go ahead and write it out. So I'm going to start with my first term. And then my common difference is negative, so I'll put a minus this time. And that is the explicit formula for my arithmetic sequence. Sometimes you might see this where they have distributed the -2 and gotten rid of the parentheses. So I'm going to go ahead and do that work real quick so that we just remember that that is a possible way to have written the equation. So 27 minus 2n plus 2. So you could have written -2n plus 29. So that right there would be possible, and you might see this sometimes as you're plugging it in. But this is an acceptable answer over here. All right, for geometric, let's do 3, 6, 12, 24. So we're looking at that sequence that we looked at a moment ago. So on this one, if I look, I can see that my first term is 3, and I can see that my pattern is it's multiplying by 2. So I'm going to say the a sub n, and then it goes first term, r, and n minus 1. So my first term is 3, my r value is 2, and then I have my exponent there. And that should be a review, so hopefully you're looking at that like, yeah, this is boring. Okay, so what I really wanted to review was some of the ones that get a little bit more complicated, not terrible, but just a little bit more, that you might have struggled with in the past. So the instructions are the same. We're still going to write an explicit formula, but this time the information is going to be different. So we'll say this time they're going to tell us that the common difference is negative 200, and then they're going to tell us that the 52nd term is negative 10,162. So here we don't have the first term, clearly. So I'm going to go ahead and write out the formula so we can think about what we need and what we have. So we have the common difference. That means we have the negative 200. We don't have the first term. I for sure don't have that. But I do know that the 52nd term is this. So I'm going to say for the 52nd term, I would get negative 10,162. So if you look at all the information I plugged in, that's enough that I can now figure out what the first term is, and then I'll be able to write my sequence. So if I do negative 200 multiplied by 51, I get negative 10,200. And then if I go ahead and add this to the other side, I'll get that the first term is 38. So the sequence would be 38 minus 200 times n minus 1. Let's say they gave us that the common ratio was 3, and that the 8th term is negative 4,374. So again, I'm going to write out the formula and then plug in the things that I know for sure. So I know that the common ratio is 3. I don't know the first term. I do know that the 8th term, so I'm going to plug that in here, 8 minus 1 is negative 4,374. And then I can go ahead and work from here. So 3 to the 7th power is 2,187. And so if I divide that over to the other side, I'm going to find that a sub 1, the first term, is negative 2. So my formula would be negative 2 multiplied by 3 to the n minus 1. Okay, and then last, just 2 more examples. Let's say they're giving you 2 terms. So if they only give you 2 terms, they have to tell you what type of sequence it is, because it could be multiplying between those 2 terms or adding. So here I'm going to tell you that we're dealing with an arithmetic sequence, and I'm going to tell you the 4th term is 3, and the 20th term is 35. This kind of works like those fill-in or the missing term problems where you had to fill in those blanks. So we're going to approach it the same way. If it's arithmetic, I know I'm adding consistently between these. So I'm going to say 35 take away 3 means that altogether we have added 32 numbers as we've gone up. And then I want to see how many terms it has taken me to do that. So 20 terms take away 4 is 16. So that means that we have gone up 32 numbers over the course of 16 terms. And 32 divided by 16 is 2. So that means that the d value here is 2. And so now it's switched to like our last example, where now we have the common difference, and we have either one of these we could use. I'm going to go ahead and say the 4th term is 3, because the numbers are smaller. And then we just plug that in. So the 4th term is 3. I don't know my first term. I know my common difference is 2. And I know I plugged in 4 to get the 3. So I plugged in 4 to get this 3 over here. So 3 equals the first term plus 6. So negative 3 is the first term. Alright, and then one last one. We're going to do a geometric, of course. So we have our third term is 48, and our sixth term is 3072. So just like when we were finding the missing terms, we want to know how many times we've multiplied a number to get this difference between the numbers here. So I'm going to divide these to see what number we have multiplied by overall. So 3072 divided by 48 is 64. And then I want to know how many terms are in between here. So between the third term and the sixth term, you guessed it, is 3 terms. So I'm going to say the same number multiplied by itself 3 times is 64. I'll go ahead and third root that. So R is 4. So the pattern is we're multiplying by 4 each of those times. So I'm going to use R equals 4, and I'm going to use that the third term is 48. So I know that my third term is 48. I don't know my first term. I know that I'm multiplying by R each time, and I know that to get that 48, I must have had a 3 minus 1 up here. So 48 equals the first term times 16. And so the first term must have been 3.